In this video, we're going to take a look at a data set that has 12 different data points. We're going to take all those data points and create a 5-number summary, and then we're going to figure out what the IQR is and if there are any outliers or how to figure out if there are any outliers. And then we're going to take a look at all that information, create a box plot, and then figure out some interpretations based on that information. And if you'd like to download a free copy of this blank PDF, you can find a link to that below. I encourage you to grab some paper, something to write with, and let's do some math together. So what's our situation here? It looks like Adam is going to be running for 12 weeks and he's going to be running different amounts of miles throughout those given weeks. The first thing I recommend doing here is writing our values from least to greatest so we have them in order. So I think we're going to go ahead and say 0 miles is going to be the least amount. I'm going to go ahead and cross them out as we go. After that, it looks like 4 is the next biggest number here. After 4, we have 6. I'm going to write 6 and then cross it out. After 6, we have I think 2 8s here, 1 8 and then 2 8s. So I'm going to write those here, 8 and 8. After those 8s, I see a 9 and 11. So I'm going to go ahead and write a 9. I'll cross out the 9 and 11 and then write those in. Now after that, I see a 12 and a 14. So I'll go ahead and write 12 here and 14. After that, I see a 15 and then a 16 and then finally a 24. Once we have all our data points in order, we can go ahead and find out our 5-number summary. So the first one here is going to be the minimum. So the minimum is just going to be the smallest number, and that's going to be 0. So I'm going to go ahead and write the minimum here is going to be 0. Now that we have our minimum, let's go ahead and figure out our maximum, because that's going to be pretty easy to figure out here. So the maximum is going to be the biggest data point. That's going to be 24 miles. So in those 12 weeks, there was a week where Adam ran 0 miles, and then there was a week where he ran 24 miles. So that's the minimum and maximum mileage during these 12 weeks. After that, I think the median or quartile 2 is going to be the next easiest thing to find. Now there were 12 weeks in total. So we're going to go ahead and group the 6 weeks where he ran less miles, and then group the 6 weeks where he ran more miles. If there were an odd number of data points, we would see our median right away or our quartile number 2. However, in this case, we have an even number of data points. So this means that we're going to cut our data set in half where we have 6 and 6. To find the median, we have to figure out what's exactly between 9 and 11. So to figure out what's between 9 and 11, what we're going to do here is we're going to just find the average of 9 and 11. So we can take this 9 and then add 11 and then go ahead and divide that by 2. Right? So 9 plus 11, that's going to be 20. 20 divided by 2, that's going to be 10. And you might have been able to tell that just because 10 is right between 9 and 11. So up to you how you want to do that. But if the numbers are a little bit messier, you can go ahead and find the average of those two values to find the middle. All right, so moving on to the first quartile, this is going to be basically looking at the middle of the bottom half here. So specifically, we're just going to be looking at this bottom half for a moment. If we look at the bottom half, we can see here that we have 6 data points. So if we go ahead and cross off on both sides here until we find the middle, the first quartile is going to be halfway between 6 and 8. So again, if you want to go ahead and show this work, what we can do is we can say 6 plus 8, go ahead and add those two and then divide by 2. 6 plus 8 is going to be 14, so it's going to be 14 divided by 2. So halfway between 6 and 8 is going to be 7. So this is going to be our first quartile. All right, for our last 5-number summary value, this is going to be the third quartile. So if the first quartile was going to be in the middle of our lower half, the third quartile is going to be the middle of our upper half. So our upper half is going to be right over here. We have 6 values. So let's go ahead and look and see what is going to be the median of those 6 values. Since we have 6 of them, it's going to be right in the middle of 14 and 15. So this one is not going to be a nice number in the sense that it's going to be a decimal. So we're going to go ahead and average these. So 14 plus 15, go ahead and add those. We don't really need these parentheses. I'm just writing them just in case. 14 plus 15 is going to be 29. And then half of 29 is going to be 14.5. So the third quartile is going to be 14.5 here. So there's our 5-number summary. We know that the least amount of miles Adam ran in a week was 0. We know the most was 24. We know the median was 10. So half the time he ran more than 10 miles in a week, half the time he ran less than 10 miles a week. And then we have this first quartile of 7. So 25% of the time he ran less than 7 miles, or 75% of the time he ran more than that. And we have a third quartile, so 25% of the time Adam ran more than 14.5 miles, but 75% of the time he ran less than 14.5 miles. Let's move on to part B now, where we're going to find out the IQR, or interquartile range, and see where the outliers would be. So to calculate the IQR, or interquartile range, we're going to take the third quartile and subtract the first quartile, or find the range or difference between these two values. So for the IQR, it's going to be quartile number 3 minus quartile number 1. That's how you find the interquartile range. Quartile 3 was 14.5, or is 14.5 miles, minus quartile 1, which is 7 miles. So we know we have an interquartile range of 7.5 miles, right? So this right here basically just tells us that the range of the middle 50% of the data, or the amount of time that Adam ran miles, had a spread of 7.5 miles. Well, what about the outliers? How do we figure those out? Well, first what you're going to have to do is find the IQR, which we already did. Now the IQR was 7.5. So the magic number we need to look for here is going to be 1.5 multiplied by whatever the IQR is. So that's the first step we're going to do when we're looking for outliers. Now our IQR is going to be 7.5. So let's go ahead and take this 1.5 and then multiply it by 7.5. Now feel free to pause and do that calculation, or use a calculator. If you go ahead and multiply 1.5 times 7.5, that's going to be 11.25. So the first step for finding out if we have a low or high outlier is always going to be taking 1.5 and multiplying it by the interquartile range, and that's this value that we're going to get for this particular data set. So that's going to be step 1. Our second step is going to be using this 11.25 with quartile 1 to figure out if there are any low outliers. So let's go ahead and do that real quick. So to figure out if we have a low outlier, what we do is we take quartile 1, which we said earlier quartile 1 is going to be 7, but I'm going to go ahead and write the formula down. Quartile 1, and then that's the lower side, so we're going to go ahead and subtract this 11.25. Okay, so quartile 1 minus 11.25, quartile 1 we said was 7. So 7 minus 11.25, that's going to end up being a negative value, right? It's going to be negative 4.5. So what this actually means is that if Adam ran less than negative 4.5 miles in any given week, then that would be considered an outlier. While it doesn't make sense to have any negative values in this particular case because we're talking about distance and the amount of miles that Adam ran, you can maybe imagine in a different scenario if we're talking about elevation, or we're talking about temperature, we're talking about money or finances, that you could have negative values. So you could have negative outliers that are negative. Now, what about calculating to see if there is a high outlier, or an outlier on the high end here? So if we used Q1 for the lower outliers, then we're going to go ahead and use Q3, or quartile 3, for the high outlier. So we'll take quartile 3 and add 11.25 to figure out if there's anything on the higher end that is considered an outlier. And so quartile 3 here we said was 14.5. We figured that out earlier. We're going to go ahead and add on 11.25 and see what that's going to be. Looks like that's going to be 25.75 miles. So that means that anything that's higher than 25.75 miles would be considered an outlier. Now it looks like our greatest data point here is 24 miles. That's 24 miles in a week. So that's less than that. So we're going to say there's going to be no high outlier. So to figure out if there was a low outlier, we would have to say that X, let's just say X would represent the amount of miles that Adam ran in a week, would have to be less than negative 4.5. Or to be an outlier on the high end, X, the number of miles that Adam would run, would have to be greater than 25.75. So since we don't have any data values that are lower than this negative 4.5 or higher than this 25.75, we don't have any outliers for this problem. Alright, let's go ahead and create a box plot now. So when we're making a box plot, we need a number line. So if you don't have one already, we just have to go ahead and create one. So just draw a nice straight line, and then our minimum value, it looks like, and our box plot is going to be 0. So I'm going to go ahead and put that over here to the left. We have to go all the way up to 24. I think what I'll do is I'll skip count by 2s here, but I'll label every other one here. So I'll go ahead and say this is going to be 2, and this will be 4. Go ahead and just try to take your time and skip count the best you can and make it as neat as you can. So this will be 8. This would be 10, so this would be 12 over here, then maybe 14 and 16. Then we'll go with 18 and 20. And then finally 22 and 24. If you wanted one more line here for 26, I'll go ahead and put that. Once we have our number line, let's just go ahead and figure out what our 5-number summary was. So our minimum value was going to be 0. So let's go ahead and just draw a line over here at 0. Then our maximum value was 24. So we can just go ahead and draw a little line over here at 24. Our median value, or our second quartile, was 10, so that's going to be between 8 and 12. So go ahead and see if we can label that. That's going to be 10. And then our first quartile was at 7, so we know 7 is going to be right between 6 and 8, so I'm going to go between these two lines over here. And then we also have this third quartile of 14.5, so look for where 14 would be and go a little bit past that, so maybe somewhere like here. Okay, so what's going to happen each time when we make these box plots is we're going to go ahead and make a box that includes our median and first and third quartile, so something that looks like this. This is where 50% of our data is going to be. And then if we look over here, this is basically where the top 25% of our data is going to be. And then if you look over here, this is going to be where the bottom 25% of our data is going to be. Because it's hard to tell and it's not always the most accurate if we're drawing by hand, it's always good to label them. So I'm going to go put a 0 here and put a 24, so no one has to guess what these values are. The median is 10. I'm going to put that in the middle, kind of where that median value is. That line represents the quartile 2, or the median. And then we have our lower and upper quartiles of 7 and 14.5. There's our minimum. There's our maximum. Here's our lower quartile, or quartile number 1. There's our upper quartile, or quartile number 3. And there's our median, but we also call this quartile 2. And earlier we found the IQR, which was going to be the range of the middle 50%. And you can see here that the range here is going to be 7.5. So the IQR here is basically the range, or how far the middle 50% is going to be spread. So from 7 to 14.5, it has an IQR of 7.5 we found earlier. All right, now that we figured out how to draw our box plot and we have everything labeled, let's see if we can understand and interpret all of our data here. All right, so now for some interpretations. Let's see if we can understand everything that we just did. So for this first one, 25% of the time, Adam ran more than how many miles? Well, this is going to be more than the third quartile, because remember, each of these quartiles represents 25% of the data. So 25% of the time, Adam is going to be running more than 14.5 miles. So I'm going to go ahead and write that in here. That's 14.5. If you look down at our box plot, that should be pretty clear here, just because each of these sections of the box plot represents 25% of the data. So 25% of the data is between 0 and 7. Then our next 25% of the data is going to be between 7 and 10 miles. We have 25% of the data, which is going to fall between this 10 miles and 14.5 miles, and then 25% of the data is going to fall between 14.5 miles and 24 miles. So when the question asks us about 25% of the data is more than what number, that's how we know it's going to be more than 14.5 miles. For this next one, 25% of the time, Adam ran less than how many miles? Well, if we take a look here, 25% of the time, Adam must have been below what mileage? Well, it looks like that's going to be below 7. That's going to be 25%, or the lowest 25% here. So it's going to be below 7 miles here. So let's go ahead and put that in. That's going to be below 7, or less than 7. All right, next, 75% of the time, Adam ran more than how many miles? So let's see where we can find 75% of the data. So it looks like that's going to be anywhere past, and when I say past, I mean above this line or to the right, because it looks like we have 25% plus another 25% plus another 25% all the way over to here. So it looks like this would be 75% of the data would be above 7 miles. So let's go ahead and say here that 75% of the time, Adam's going to be running more than, and it's still going to be 7 miles, similar to the last one. Next, we see that 75% of the time, Adam ran less than how many miles? So less than means going to be lower. So let's see, if we go from this number of 14.5 miles and we go to the left here, this would be 75% of all the data would be less than 14.5 miles. So let's go ahead and say that's going to be 14.5. Next, we see that 50% of the time, Adam ran more than how many miles? Well, if we take a look at our box plot, 50% means we're talking about where the median is, right? So 50% of the time, Adam's going to run more than 10 miles. And on that same bit of information here, 50% of the time, he would run less than 10 miles. So I think we can answer a couple questions here, but 50% of the time, Adam's going to run more than 10 miles. But also, that means that 50% of the time, he's going to run less than 10 miles. So it's kind of a 2-for-1 deal there. Next, 100% of the time, Adam ran at least how many miles? So 100% of the data is going to be at least what number? Well, 100% of the data is going to be above 0. So here's 100% of the data. So we're going to go ahead and say that that is going to be 0 or more, right? And then for this next one, 100% of the data is going to be at most how much? Well, at most it's going to be 24 because that was our maximum. And you can see 100% of the data is to the left of that, right? So Adam ran at most 24 miles 100% of the time. A couple trickier ones here. The middle 50% of the miles that Adam ran was between blank and blank miles. So the middle 50% is going to be from here to here. This is always talking about that IQR. So the middle 50% is going to be between 7 and 14.5. It's going to put 7 and 14.5, basically Q1 and Q3. The range of this number of miles is called and this is called the IQR, or the interquartile range, or the range of the middle 50%. All right, next, if there was a low outlier, we talked about outliers earlier, right? We said that earlier. We said there were none, but if there was a low outlier, what did we say? We said it had to be below this negative 4.5. So we're going to go ahead and say it would have to be below negative 4.5 miles, which we didn't have any. Next, if we were to have a high outlier, right, a high outlier, we've calculated that earlier as well, then what would that have to be? We said for the high outlier that it would have to be more than 25 3/4 miles, but we didn't have one. So if there was one though, it would have to be above 25 3/4 miles. All right, one final question. This one is going to be a little bit trickier. So the upper 50% of the miles that Adam had run had what type of variability compared to the lower 50% of the miles Adam ran because of why? So let's see if we can figure this out. The upper 50% is going to be from here to here. And what was the variability? Well, it looks like it ranged from 10 to 24. So what's the distance between 10 and 24? It looks like the upper 50% had a spread. I'm gonna go ahead and write this down. The upper 50% had a spread of 14, right? They're 14 away from each other if you look at that. And so the upper 50% of the data is spread amongst 14 miles. And what about the lower 50%? The lower 50% was between here and here. And what is that spread? It's between 0 and 10 miles. So if we see the lower 50%, let's go ahead and write that in. The lower 50%, that was 10 miles apart. So the question is which one had a greater spread? So we can see here that the upper 50% of the data had a spread of 14, but the lower 50% of the data had a spread of 10. So we would say that the upper 50% of the data had greater or more, either one you can say, greater variability than the lower 50% of the miles that Adam ran, just because it was spread out more or had more variability. Now, how do we know that? We knew that because the range, or you can say the spread as well, the range of those miles is bigger or greater, right? The range we got was 14 versus the range of the lower 50% was 10. So because 10 is less than 14 or 14 is greater than 10, we know that the upper half of the miles that he ran was more spread out than the lower half of the miles that he ran. Now, putting this all together, just keep in mind that when we're dealing with box plots, we can take a data set and summarize it with 5 specific numbers. That's our 5-number summary. And then those 5 numbers help us break the data into 4 categories of 25%, 25%, 25%, and 25%. These are all called quartiles, and we can figure out how much or how little data is spread out given that information. If you found this video helpful, please consider giving it a thumbs up. And as always, keep up the great work that you're already doing.